Okay, so today we're moving on with something called percent yield. And what does it mean to yield something? Kind of, yeah, produce, create. Okay, so percent yield means we're going to look at how much we produced or created in comparison to how much we think we should have. Right? We're looking at what percentage of our experiment or of our reaction went to completion. Okay? So everything that we've been doing so far has been calculating a theoretical yield. What's it mean for something to be theoretical? Yeah? Close, right? Yeah, it tells us what should happen, right? It's expected. This is what is expected to happen. So the theoretical yield is what's expected to happen. That's not always the case when we get to a real lab scenario, right? So everything we've done so far is going to be looking at our theoretical yield. What we do to find our percent yield or find how much percent was actually yielded, right, depends on this equation down here. The actual amount, which has to come from the lab. So this is only given from a real lab scenario. Divided by our theoretical yield times 100 gives us the percent of our product or whatever we were looking at yield. Okay? And so theoretical yield always comes from our T-chart. Okay? Theoretical always comes from our T-chart. The actual yield comes from this experiment itself, or it'll be given to you in the problem, right? It says it actually yields this much. Okay? So theoretical always comes from our T-chart. Actual will be given to you, or maybe you'll solve for that based on the percent yield, something like that. But our theoretical yield always comes from our T-chart. Okay? So theoretical T-chart. Okay? Most of the time you'll see me write percent yield as just actual over theoretical, right? So A over T. A being the actual, T being the theoretical. Okay, so calculating percent yield is extremely simplistic. It's taking the stoichiometry calculations we've been doing just one step further. All right, so I balanced your equation for you. Can anyone tell me, first of all, what type of reaction this is?
Double displacement.
No. Combustion, right? We start with a hydrocarbon plus oxygen yields carbon dioxide and water. So this is a combustion reaction. Combustion reaction. Okay. How many grams of water will be formed if 36.5 grams of oxygen are used? So from now on, most of our calculations will typically be gram to gram. Okay, we know how to do all variations of our stoichiometry calculation, but for right now, most of them will be gram to gram. So we need to know how to do that. Okay. How many grams of water will be formed if 36.5 grams are used? And then it wants to know what's the percent yield if only 7.95 grams are actually formed. Okay, so we're going to use our T-chart to find what type of yield. Theoretical, right? We're going to find our theoretical yield from our T-chart. So the way we do that is we always start with what we know. So if you might need your periodic table out or your calculator for sure. But we're going to start this T-chart with what we know. Oxygen and not oxygen gas. Right? What's the only version of oxygen in our balanced formula? O2, right? Our oxygen gas. So even if it doesn't specifically say oxygen gas, you still need to use O2, not just O, right? So our molar mass for O2 is 32, not 16. Okay. So you always use a formula or a compound that's found in your balanced reaction. Okay, so to go gram to gram, I need to go grams to what? Moles, then to mole ratio, right? And then back to grams. So we need to go through 4 steps here. We'll go grams of O2 to moles of O2. 1 mole is equal to 32 grams. Now I need moles of O2 to moles of, yep, good, moles of water. And where do these numbers come from? From our reaction, right? Those are our coefficients. So water gets a 3, O2 gets a 6. Now if I stopped right there, what would my units be? Moles of water, good, or H2O. So I want to keep going because I want to go in our percent yield, it needs to be grams and grams, right? Or moles and moles. So since in our yield equation it says grams, we need to go all the way to grams. So I go moles of water to grams of water. Molar mass of water is 18. I've canceled all my units correctly. Now I can do the math, multiply across the whole top, divide by the whole bottom. What did we get? 10.3 grams of H2O. Okay. So now the second part of our question asks, what's the percent yield if only 7.95 grams were formed? So that means we took it to the lab, we did a reaction, we weighed our product of water, and we only got 7.95 grams. So I'm going to take 7.95 grams divided by 10.3 grams. All right, that should come out as a decimal, so you need to multiply it by 100 to get it to a percent. Okay, and we got somewhere around high 70s, low 80s percent. 77 point what? 77.2%. Okay. Theoretically, right? Theoretically, should our percentage ever come out greater than 1 or 100?
No.
Right? Theoretically, no. Does sometimes it happen in a real lab? Yes, because we do something wrong. But in our calculations, theoretically, that percentage should not come out over 100. Right? Any questions here? If this was given in moles, right, we would need to have stopped in moles here on our T-chart. Okay, when we do percent yield, these units have to match. Okay, you can compare them mole to mole, or you compare them gram to gram, but you got to match. Okay, so if it said 7.95 grams and we tried to put moles on the bottom, that would not work for our percent yield. Okay. Same balanced equation here. It says, if a reaction of 40.8 grams produces a 39% yield, how many grams of water will be produced? So this tells us a couple different things. Okay. Right now it tells us our percent yield of what compound? Yeah, it tells us the percent yield of water, right? Because it says it produces a 39% yield. How many grams of H2O will be produced? So what do you think that means overall we're solving for here? Grams of H2O. Okay, our actual yield or our theoretical yield? Right? Overall, we want to find our actual yield of H2O. Okay, knowing that we're going to have a 39% yield. But what's the thing that we're missing to help us get there? The theoretical yield of water. Okay, so right now we have a starting amount of our hydrocarbon. We have our percent. We need to solve for the theoretical yield of water, right? How much water should be produced. And then we can take that 39% and help us find out how much was actually produced. Does that make sense? Where we're working with that? Okay, so let's start that. So 40.8 grams of our hydrocarbon. What did we have for our molar mass of our hydrocarbon? I'm hearing two different things. One what? 126. So 72 plus 6 plus 48. Okay. 12 times 6 is 72. Yes? No? Okay. Did we get 126? Yes or no? Because I didn't do the math. Okay. So we're done with grams. We're done with moles. We're done with moles. We do the math and we get what for our theoretical yield of water? 17.5 grams of H2O. So now we know if our percent yields 39%, you need to convert that to a decimal place before we plug that into our equation. So the ratio is not 39 equals actual over 17.5, right? This needs to be put back into a percent, so it needs to be 0.39 equals actual over theoretical. Okay, so this is really important, putting that back into a decimal. To solve for this variable, what do I need to do algebraically? Multiply by 17.5 on both sides. Okay, and we should get a pretty low number, 5 something, 6 something. 6.8 grams of H2O. Okay. Any questions here? All right, let's try one last one on your own. I already answered it for you, sorry. I jumped the gun. Okay, if the reaction... Sorry, one more time? What do you think? Just look at it. Yeah, it's balanced. Yeah. Just check before you go. Yeah, because we have 3 oxygens, 2 and 1. So yeah, it's balanced. Okay? If the reaction of 20.7 grams of calcium carbonate produces 6.81 grams of calcium oxide, what is the percent yield? So is this 6.81 your actual yield or your theoretical yield? This is our actual yield. So you need to solve the theoretical and then find your percent composition. Percent yield, sorry. It's kind of just by reading the problem. So you have to use context clues to help you determine is it actual. Theoretical will always come from your teacher. So it's very rare that they would give you a theoretical. Because you can always calculate that. Okay.
It's one of your two lines. It's calcium and carbonate. CAC. Egghead. Good to go.
How many of you got that answer? 58.7%. Okay? To get there, we went from 20.7 grams of... Listen. We went from 20.7 grams of calcium carbonate to some number of grams of calcium oxide. So it had to have been about 12, 15, I don't know, somewhere in there. Okay? We take 6.81 divided by that theoretical answer you got from your T-chart, and you should get about 58.7. Okay? Any questions with percent yield? Okay.